students who are in grade and below, and it is a 40-minute MCQ contest with 25 questions. The total mark is for 25 with no negative marking. AMC 8 is for the students who are in grade 10th and below. It is a 75-minute MCQ contest with 25 questions. The total mark is 150 with no negative marking. However, 1.5 mark is granted for unanswered questions. And this AMC 12, which is also for the students who are in grade 12 and below, and it is a 75-minute MCQ contest with 25 questions. The total mark is 150 with no negative marking. However, there is also a 1.5 mark granted for the unanswered questions. The cutoff mark will be different for all the years. So the students who perform well on the AMC 10 and 12 examinations are invited to participate in the American Invitational Mathematics Examination, that is AIME. Students who perform well on the AIME are then invited to the United States of America Mathematical Olympiad, that is USMO, or United States of America Junior Mathematical Olympiad, that is USAJMO. But USAMO is only for the US citizens, others cannot participate in a USMO. The AMC 10 assumes knowledge of elementary algebra, basic geometry knowledge, including the Pythagorean theorem, area and volume formulas, elementary number theory, and elementary probability. What are excluded are trigonometry, advanced algebra, and advanced geometry. The AMC 12 covers the entire high school mathematics curriculum, including the above, as well as the trigonometry, advanced algebra, and advanced geometry, but excludes the calculus. And so this is a basic orientation for the AMC, and now the classes will begin, and it is being taken by Mr. Aditya Verma. And now I'm handing over the class to Mr. Aditya Verma. He'll be taking the classes for AMC 8 sessions today.
Good evening, students. I'll start the uh, class in a minute. Okay. Short introduction of me. My name is Aditya Iyer, not Aditya Verma. There might have been some miscommunication. No issues. Today I'll be starting with some combinatorics. Basics of it. We'll not be reaching the complete level of AMC8 in today's class anyways. Uh, I'll give certain tougher questions are on the that are at par with the most difficult questions in AMC8 as bonus questions, but mostly I'll be doing very basic stuff so that a majority of the students in the class are covered. Uh, I'll start with today's lecture. Just keep this aside. You can note this down. Okay. This is a bonus question. This is not the question that I'll be discussing right now, but in case you get the answer to this, you can send it on the chat. There is no point in Googling the questions that I'm giving you because that won't add to your knowledge. You just try to solve them on your own. Whoever gets the answer to this, just send a chat, send a message on the chat. Okay, we'll start with question 1. How many 4-digit passwords exist? Yeah, repetition is allowed. So it's just normal passwords. Like you open up your phone, how many 4-digit passwords can you set as your password? That's the question. I'll explain 2 ways to actually go about solving this problem. Okay, Rajeshri correct, Arnab not correct. Try again. Pratiksha not correct, Omkar not correct. Chiteshwar not correct, Parul not correct, Saraswat correct, Yash not correct, Ishan correct, Devansh not correct, Arnab correct, Ruchiket not correct. Okay, see, I see a lot of you are answering this question, but uh, around 30% of you are getting the answer. I'll make the question a bit simpler. How many 1-digit passwords exist? This is a simple question. Like you open up your, this is when I say 4-digit, I mean that it's a numeric password. Okay, it's not alphanumeric. So like 0, comma 1, comma 2, dot 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 all the way up to 9. These are the allowed digits. Okay, so 1-digit passwords, you can obviously know okay, there are only 10 of those available. For 2-digit passwords, all the way from 000102 dot dot dot. I'm not saying how many 4-digit numbers exist. The question was how many 4-digit passwords exist. So some of you are giving the answer as 9,000. That is not correct. Uh, so all the way from 000102 dot 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 up to 99, you see there are 100 numbers or 100 passwords possible. So like extending this argument forward, you can see that 4-digit passwords will be all numbers from 0000 to 9999, and that will be 10000 or 10 to the power 4. Okay, so both of these are acceptable answers in case you had given these. Again, remember that I'm saying 4-digit password. So in your password, you can start with 0, right? There is always, it's allowed that your password starts with 0. I hope everyone has understood this. Uh, I'll show another method to actually you can call this method 1 to answer this particular question. Another method to answer the same question can be the combinatorial way of actually solving this question. Here we did a counting. We assigned that each password 000 is the first password, and then 999 is the last password. 9999 is the last password. So that's why you can say that there are total 10,000 numbers in this list, because they are like natural numbers going from 0 to 9,999. They are 10,000 in number. Hence you got your answer. Another method of asking will be the combinatorial way, or solving this question can be the combinatorial way. Ask each place which what number must it have. Okay, so uh, let's call this position 1, 2, 3, and 4. So each position 1, 2, 3, and 4 has 10 choices. Correct. So you can sort of say that this position has 10 choices, this has 10 choices, this has 10 choices. Each of those 10 digits can come over here. So you can say that the total choices will be 10 times 10 times 10 times 10, and that is 10 to the power 4. Okay, so just go through this what I've written. Some of you want to see the bonus question again. You can keep working on this. I suggest just take a screenshot first of all for this bonus question, so that you can keep working on it if the rest of the class seems easy. Okay, try out question number 2. Given a set A equal to A comma B comma C, find how many subsets set A can have. Okay, many of you are having the same question again and again in question 1. 0 can be the first digit in a password. Okay, we are not saying how many 4-digit numbers are there. It's just saying a password, so 0 is allowed as the first digit. In question 2, acha, some of you are asking what is a subset. So B is a subset if all elements of B are in A. So I'll give you an example. This question, of course, you can solve it by listing, but then I'll show you another faster way to go about doing it also. I'll give you 1 minute to solve it. Think about this definition and then get your answer. Okay, very few of you are getting the correct answer. Yeah, I can't pick out each one of you from the chat and say if your answer is correct or not. Uh, should I start solving it, or do you guys want me to wait? Okay. So for this question, I'll actually first of all define what a subset is, and then I'll also I'll list out all the subsets. Okay, for this question, this particular question, I can do that. So this subset A comma B comma C is a subset. Then you can have another subset where you have A and B, and then you can have one where you have A and C. You can have one where you have B and C. Then you can have a set where you have only B. You can have a set where you have only A, and a set where you have only C. And you can have the empty set also. Okay. Empty set is also a subset of every set because every number inside this is in here. It doesn't matter if there is no number inside here. This is a theoretical point. So you found that there are total 8 sets over here. Correct. Method 1. This is by simple listing all possible subsets. We get 8 subsets. Okay. Now the question is, what if we had what if I increase the difficulty of this question? Can you think about a combinatorial way to get to the answer of this question? If you have given A is equal to A, B, C, D, E, F, how many subsets exist? Try to ask the same question that you had asked in method 2, but make it sort of for this subsets wala question. Okay. Whoever has answered correct for this question. Cheteshwar, try again. Arnab, correct. Juhan, try again. Ajinkya, try again. Cheteshwar, Lakshita, try again. Soumya, try again. Krishna, correct. Nauman, try again. See, if I'm not saying your name, then your answer is correct. Brijeshta, try again. Ruchet, try again. Cheteshwar, not correct. Man, not correct. Nibansh, not correct. Anshdeep, correct. Ajinkya, try again. Abhijit, correct. Devansh, not correct. Pranayam and Kaushik, try again. Okay, I'm not saying right now because too many of you are putting in the chat. So, see, I'll give you one hint. Answer is greater than 50. Answer is greater than 50 and it's less than 70. Okay. So, if you're not getting answer in this range, then answer is not correct. Anupam, I'm not aware of the recordings. You can directly contact Transition Lab Preparatory School about it. I don't have access to the recordings or have ability to send it out. Harush, correct. Sharav, not correct. Saraswat, you are very close to the answer. Just think about what's written in the bonus question a little bit more. It is asking numbers that are less than 1. So keep that in mind while answering this particular question. Lakshya, not correct. Nibansh, not correct. Redmi Note 9 Pro, not correct. Okay, I think I've given enough time to solve this question. See, here it's physically possible to actually list out all the possibilities. But while listing out all the possibilities, you yourself will stumble on the correct way of actually solving it. Think about it. In your subset has to have all the numbers among these. Okay. All the elements among these. So you can directly, when you're listing it, you can start with, okay, no element exists in the subset. Then A exists or B exists or C, D, E, F, all of these. Then every two pairs. So AB, AC, AD, AE, AF, and then BC, BD, BE, BF, CD, CE, CF. and so on. You can just keep going on listing out all of them, but someone someone has actually listed all of them. Okay. Uh, Not all of them, but other two element pairs someone has listed. But it's a lengthy process and it doesn't give you the answer very fast. What you can do is over here is ask each element if you want to be in the subset. Think about it. Each element has a choice to be in the subset or not. And each choice will give a different subset. So you go and ask A to be in the subset or not. If A says that, yeah, I will be in the subset, that is one choice. If A does not want to be in the subset, then that is second choice. So there are two choices for each of these elements. And in line with this question also, you can again see कि A has two choices, B has two choices, C has two choices. So you can do 2 times 2 times 2, and that result is 8. Correct? So you have a proof of concept also कि this manner of reasoning actually works. And you can write number of subsets is equal to 2 to the power hashtag A, where this means is equal to number of elements in set A. Okay, this is a like standard notation when you are dealing with number of elements of a particular set. You can also say that when A is a set, this is also the same thing. When A is a set. Okay, so that way your answer will be 64 because there are 6 elements over. If anyone has doubts, then take a screenshot of this. Ask your mathematics mentor wherever you are studying, either in your school or in your some coaching class if you have joined. Ask them that I joined a particular class and this was discussed. Can you please explain it? In case you are not able to understand it. Because there are about 100 students over here now. So I can't individually unmute and ask you if you have understood it or not. The concept here is simple, that you go and ask each element whether you want to be in the set or not. Okay. And the more questions you do, the this will keep getting easier and easier. Again, I'm saying if you are finding these questions very easy, Krishna, correct answer. Good. Try this question. So we've done 3 questions. Fourth question. How many ways to arrange 3 cards in a row? Okay, and these 3 cards are distinct. Okay, so suppose you have a ace, you have a king, and you have a queen, all different cards. How many ways can you arrange these 3 cards in a row? First of all, this is a tiny case, so you can do the listing. Okay, do the listing, get the answer. All of you are getting correct answer. Ruchet, try again. Arush, try again. Okay, any answer greater than 10 is wrong. And any answer, yeah, I'm just telling that any answer if you're getting greater than 10 is wrong. Just a second. Okay, those who are done with question 4, because it's very easy, uh, you can try this question instead. No, I won't give the answer to this question for the next 5 to 6 classes. And I suggest you don't Google up this question. You'll get the answer to it quite quickly. But rather spend like about a month thinking on your own about this problem. Only start doing this if you are done with the first bonus question. Okay. Saraswat, correct. Yeah, this is a 8x8 board. And I'll come back to question number 4. So it's simple. You have 6 ways of arranging these. And those ways are A, B, C, A, C, B, B, C, A, B, A, C, and then C, A, B, C, B, A. You can see all these 6 cases are distinct, and there are no other cases beyond these that are possible. So, is there a trick to solving this question? Can you do it combinatorially? Can you ask something? Here, the question cannot be asked to each card, because if card A goes to one of these slots, actually it can be asked to the cards, but it's better to actually ask the places, uh, because in other cases it's usually beneficial to ask the positions, what is happening. So here what you can do is, this is method 1, just simply listing it. Method 2 is that ask each position. In this particular question, you can actually define the first, second, and third position, correct? And you can ask each of the position whether you want a particular card to be in that place or not. Ask each position which card does it want. Okay, so position 1 has 3 choices. But once position 1 has chosen a card, that card is not available in the list for the other positions to check or choose from, correct? Position 1 has 3 choices. I'll just number them. Position 2, position 3. Position 2 has 2 choices, because one card was selected by position 1. And similarly, position 3 has 1 choice. So here the answer will be by some multiplicative principle. You have just product of all these choices, 3 times 2 times 1. And the way you can actually visualize this is, you have 3 cases. Uh, these are starts with. Either starts with A, starts with B, or starts with C. And then from here you have cases. Second is that either B or C, either A or C, either A or B. And the consequence over here is that third, this is C, B, and this will be CA, and this will be BA. So you can see that all these choices actually align with all the 6 cases that you have: ABC, ACB, BAC, BCA, CAB, CBA. Correct? So you have 3 choices here. Then each of those 3 choices has 2 choices of their own. They have one choice of their own. So that's why 3 times 2 times 1 is what you do. A neat way to actually represent is 3 factorial. I'll now define this symbol. 3 factorial, or basically n factorial, is n factorial is equal to n into n minus 1 into n minus 2 dot 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 all the way up to 1. N, or 1 factorial is equal to 1 and 0 factorial is equal to 1. These are certain things that you need to keep in mind. You also have n factorial is equal to n into n minus 1 factorial. This is the definition of factorial. This is an easy way to remember it also. That it is the product of all the positive integers from 0 to 1. Some of you will be confused why 0 factorial is 1. Shouldn't it be 0? Think about it. By this definition, 1 factorial is equal to 1 times 0 factorial. Since 1 factorial is 1 and 1 times 0 must be 1, that's why 0 factorial is equal to 1. Okay. If you try to calculate what is minus 1 factorial, it is not defined. Okay, because you cannot have a number that when multiplied by 0 gives 1. So all the negative numbers don't have a factorial. Okay, and only integers have a factorial associated with it. Once you go to higher classes, there will be factorials associated with all real numbers, but that is something we'll not be discussing in combinatorics. It's a higher, more advanced stuff. So in case those questions are coming in your head, you need to wait for at least 2-3 years to get to that point where you can understand it. Okay. Question 4 done. Let's do question 5. How many ways to arrange 6 students in a line? Yeah, you just have to find all possible ways. These 6 students are distinct people, so you can't have identical people. Uh, yeah, okay, everyone is getting correct answer. No one is getting the wrong answer so far. Or Kuldeep, wrong answer. Omkar, Misbhav, wrong answer. Rest of you, I think, are all correct. Nauman, not correct. Kushuman, not correct. Rest of you are correct. Anshdeep, very good. Correct answer. Everyone who got the answer to the bonus questions, you can message me directly on WhatsApp that you found the answer to it. Okay. Yash, correct answer. Laksh, not correct. Try again. Saraswat, also try again. Not correct. Okay. I think I don't need to spend much more time on this question. It's simple. It's like direct application of previous question, but you should have thought about it. Okay. Over here, actually, you can go and ask the student also. Ask a student, where in the line do you want to stand? Suppose it's some a line to get in for some exam or something, or some interview or something. The student might not want to be in the first position, correct? But still, there are 6 choices. So the first student has 6 choices. Second student, because one of the choices is gone, has 5 more choices. So multiply by 5. Then the third student will have 2 less choices. So times 4. So total choices will be 6 times, 5 times, 4 times, 3 times, 2 times, 1. The last student will have always one choice only. It's not no choice, but it's just one choice. And you multiply by 1 in the end, which doesn't change the answer at all. And the answer will be, you can either say 6 factorial or equal to 720. Okay. Always when you're doing such combinatorial problems, make this list of possible cases. And then you can write the number of cases on top of it, or number of choices on top of it. And then put an arrow and make 720. Okay. When we do more complicated problems, this will help. But here it is straightforward, 6 factorial. Try question number 6. How many ways to sit in 2 cars? And I'll make the car. Let's say here there is a driver. These small boxes are uh, sort of the positions where your person can sit. How many ways for, just a second, I'll just rewrite the question. This driver is not part of the setup. Okay, I can just remove this, or I can completely remove this. And you just have these 2 cars. How many ways can you make 7 people sit in these 2 cars? You can give the answer in factorial form also. Okay, Cheteshwar, correct. From this point onwards, I'll check if your answer is correct or not. I'll not go back. Ajinkya, no. Try again. Sorry, Ajinkya, correct. Cheteshwar, try again. Devansh, try again. Nauman, try again. Nivansh, try again. Avnish, also try again. See, there are 8 positions that are vacant over here. So you have to keep that in mind. So most of you are getting the correct answer. Sharav, try again. Saraswat, try again. Ruchet, Rajashri, try again. Nibansh, try again. Devansh, try again. Pranshu, try again. Krishna, correct. Soumya, correct. Yash, try again. Okay, I think I might have missed some of you guys. So I'll give you 1 more minute to think about it, and then I'll start answering this question online. Okay, so in this problem also, it's always beneficial to make uh, the slots or the positions where you are going to place your, or the platforms basically. 1, 2, I'll just count them up. 1, 2, 3, 4, 5, 6, 7, 8. So there is one more. There are 8 empty seats over here, and you have 7 people to sit in each of these seats. Now, to solve this question, it's slightly complicated. Like, you can ask each position how many people you want to seat, but then you will always be left with confused. What if each seat decides it wants no one to sit in it? So instead, you have uh, the objects in this picture, 7 people plus one ghost person. Okay, and the slots, you have 8 seats where you can actually put your objects in. Okay, so such type of problems are mainly putting the objects inside slots, and you can have 7 people, one plus a ghost person, to actually make the problem very, very simple. Now, if you ask each of the slots, they will say, okay, you can put, I can accept 8 objects. The second slot can accept 7. Then third can accept 6, 5, 4, 3, 2. And the last slot will have to accept whoever is left out. Uh, Pranayam, I can't take doubts right now because there are about 100 students. Now, if I take one doubt, then it will take the entire class to go through them. Okay, so how many ways to make 7 people sit in 2 cars with 8 such slots will be simply 8 factorial. Now think about it. Out of all these 8 positions, one of those positions will have that ghost person in it. Now, since that's a ghost person, you can just make it vanish and that one seat will remain empty. So it's like you are taking care of empty seats and you are making everyone sit in each position also. Okay. So there'll be simply 8 factorial ways. You don't need to actually calculate the value of this. You can leave it in factorial and it's correct answer. Okay. Now, question number 7. How many ways to give 5 identical coins to 5 students? One each. Think about it. Okay, Arush is getting the correct answer. Devansh correct. Kushali correct. Parul correct. Okay, now focus on when I'm saying identical coin. Devansh correct. Rest all of your answers were wrong. So think about it. If you have an identical coin, which is identical in all respects, it doesn't matter if you are switching between 2 coins. Uh, then how many ways will you have? Don't use any formula, just use common sense. What does your common sense tell you the answer should be? You have 5 students and 5 identical coins. You give each coin to one particular student. The answer should be obviously one. Okay, you don't need to do extra maths or extra thinking in for this question. I mean, the way I've defined this question, each coin is identical, but each student is different. That doesn't matter. Switching 2 coins between any 2 students does not lead to a new situation. The coins are identical in all respects. So, in this question, the answer will be 1 trivially. Or simply you can say by common sense. So, I just wanted to demonstrate a principle where objects can be identical. The situations actually don't matter if you switch between 2 coins. Okay, so keep this in mind while solving the other next question 8. Same as car problem. 5 seats and 3 people. Think about it. You have the same car problem happening, but now you have 5 seats and 3 people you want to sit inside your car. How will you do that? Okay, I see no correct answer so far. Okay, Pratyaksha and Devansh correct answer. Parul correct. Saraswata correct. Anshdeep correct. Arhan, correct. Muntazir, correct. Okay, too many of you are answering. Akshaj, correct. Arnab, the next last number that you put, Arnab, correct. Mudit, correct. Ayan, correct. Okay, like Om, correct. Zoom user, correct. I think I'll end it over here. Again, think of this question. If you want, you can mute me. Think about this question on your own. Uh, Figure out what are objects, what are the slots, and can you do this question without introducing ghosts? Introduce ghosts and then also introduce the fact that there can be identical ghosts, possibly. So remove those number of cases. I have told you the route map to solve this question. Try to think about it on your own and get the answer. Kuldeep Ishan, correct. Ajinkya, very good, correct. Geet, correct. Arpit, correct. Devansh, correct. So whoever is saying 4 factorial, I don't know how you are getting that answer. 4 factorial is not correct. Other incorrect answers are 10 is not correct, 60 is the answer. I'll start solving this question. Do some method to get the answer 60. Geet, correct. So how you will start solving this question is, first of all, establish how many objects you have. Objects you have are 3 people plus 2 ghosts. Because you want to fill all the seats with some object, correct? And similarly, you will figure out that number of slots you have is 5 seats. So we'll make our 5 seats and we'll ask each seat. Initially, we'll consider all ghosts are different. Okay. So if a seat selects ghost 1, okay, what are your objects? Your person 1. These are person 1, person 2, person 3. Then ghost 1, ghost 2. Okay. Now, if you ask each slot what person or like which object do you want to put in that slot, it will say that okay, I have 5 choices, so I'll take 5 choices, 4 choices for the next one, 3 choices for the next, and 2, then 1. These are the total choices, will be 120. But I said the answer should be 60, correct? So what will happen is, uh, let's take one particular scenario where the slot 1 takes P1, slot 2 takes G1, slot 3 takes G2, and then P3, P2. This is a particular case. Okay, where the first slot chose that person 1 should sit there. Second slot chose that ghost 2 should come. Then third slot asked ghost 1 to sit. And then person 3 and person 2. Okay, this is one particular arrangement. Then compare and contrast with this. Does it matter if we change the position of ghosts? These both are the same case as, I'll write it below here. Okay, the ghosts that we have over here must be identical because they were not a part of the original question, correct? Original question said that you have a car problem, you have 5 seats, 3 people. You introduce those ghosts on your own, and now you will decide whether they are identical or non-identical. For the purpose of getting total combinations, you assumed that they are unidentical. So each slot has a unique choice. Like the first slot has a 5 choices, 4 has 4 choices, second has 4 choices, 3, 2, and 1. But later, after you have written down or made all the 120 combinations, for each place where the ghosts have been put, if you swap them, it's the same thing. It doesn't matter. So the answer will be 5 factorial divided by 2. This comes from the fact that uh, ghosts are identical and we double counted them. Got it? So you start with a problem where you can sort of make sense of what you want to do. It's actually really tough to actually figure out which two positions will have ghosts or not. Uh, until you introduce some quantity and say that the objects are equal to the number of slots, and then you can do this factorial arrangement, 5 factorial. Then you remove the double counted cases. Sometimes it will be triple counted cases, sometimes there'll be more than that. Okay. Try out this question. Now just try to apply some formula and get the answer in terms of a formula only. Question 9. What if you have 8 seats and 5 people? Try to get the answer to this. Krishna, correct. Yash, not correct. Yash, think a little bit more. Soumya, not correct. Ajinkya, don't give me full calculated answer. Give it me, put it in factorial form. Arnab, correct. Medansh, not correct. Pranshu, correct. Devansh, I don't have the answer calculated with me. Just give it in factorial form. Okay, many of you are answering. I'll just give you 2 minutes to think about your answer. Then I will discuss it. I'll be taking or extending the class till 6:30 because I mean unless it's a conflict with transition prep school, because I think the initial 10 or 15 minutes were lost because of technical reasons. Okay, does anyone want me to wait? Just put wait in the chat if you're still thinking about the question. Okay. I'll wait for 2 minutes. See, those who are done with question 9, you can look at this question. Take a screenshot of it. I'll explain this one. Uh, it says an ant starts from the bottom left to the top right. Uh, there are two ants, okay? They travel 8 steps each. Okay. So a step over here means either going left, up, or left, or up, or this side. Each of these is a step. And they meet. They meet after 8 steps each. Okay. You have to find the number of ways in which this can happen. If you get the answer to this question, very good. Send it to me on WhatsApp. Uh, Rest of you can take a much easier question, bonus question to solve. You can contact me on this. See, you have to have the product as 20 factorial. Okay, someone is saying answer should be infinity. That is not correct. The product of numerator denominator should be 20 factorial. Okay. In next class, I will be discussing solution to bonus question 1. Bonus question 2, anyways, we'll discuss long time later. Okay, coming back to our question, 8 seats and 5 people. Uh, how to go about starting to solve this question? You have number of seats or slots, sorry. First, we'll define 8 seats. And what are the objects that we want to place inside these slots? There are 5 people, and we'll now add 3 ghosts because we want the number of objects and number of slots to be the same, because that is the way we have been trying to solve these questions, and that's the most convenient way so far. I'll change the method of solving these questions a little bit from next class onwards, where you will not have to particularly rely on ghosts. Although it's a very interesting and good way to solve it. You can just add 3 ghosts over here. So you have total 8 objects. Okay. These ghosts initially we'll consider as distinct, then we'll make them identical to remove the double counted cases, or in this case, more than double counted cases. So you have now slots that you can make 1, 2, 3, 4, 5, 6, 7, 8. And each of these has 8, 7, 6, 5, 4, 3, 2, 1. So 8 factorial cases. But there are 3 ghosts. And their internal or slash relative arrangement does not matter. Correct. So if you have 8 ghosts, I mean 3 ghosts, and their internal arrangement doesn't matter. It's like saying what are the number of ways to arrange actually 3 coins or 3 people or 3 ghosts that are identical. They are 6, correct, because of 3 factorial. So each of the case where we have G1, G2, G3, or G1, G3, G2, and so on. All these 6 cases that will sort of pop up. Their internal ordering doesn't matter. That's why the answer to this question will be 8 factorial divided by 3 factorial, which is equal to 8 factorial upon 6. This 3 comes from uh, multiple counted uh, duplicacy or okay. So that will be the answer. Those who are writing 8 factorial upon 3, that is not correct. 8 factorial upon 6 is correct. Because of those how many? 6 of those 3 goes. There are 6 possible arrangements, correct? It could be A B C, A C B, B C A, B A C, C A B, C B A. Otherwise, also you can just do 3 times 2 times 1 to figure out what's the internal arrangement or number of internal arrangements between the ghosts only. Here I'll introduce a particular notation. NPR is equal to n factorial upon n minus r factorial, where this is number of ways to arrange r objects in a line out of n possible choices. So if you try to relate to this question, you had 8 options out of which you wanted to choose 5 and then arrange among those 5. So that is what is being done here, n factorial upon n minus r factorial. And this is just for completeness, I'm introducing this symbol. Otherwise, you can make your own reasonings why your answer should be correct. And you don't have to always rely on formulas. It's not standard. Okay, now try question number 10. Find number of 4-digit passwords. Repetition. Not allowed. See again, 4-digit passwords are there, so you can have all the numbers from 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All are allowed, okay? Even 0 is allowed. Okay. Arnab Krishna, correct answer. Rajeshri, correct. Many of you are answering, so I can't individually pick out each of you and say whether you are correct or not. I'll give 2 more minutes and then I'll answer the question. Think about all that we have discussed so far. Make the first of all, choose which are objects, what are slots. Make sure that you have enough objects equal to enough slots. Now your in digits also you can have sort of boasts and then you can get the answer. Okay, I'll start solving this question. Does anyone want me to wait? Just put wait in the chat. If someone is getting the answer, I'll give 1 or 2 more.
Hi.
Yeah, Arya. Hello.
Sir, the over the section?
Should I end it or I was actually thinking I can take 20 more minutes.
Oh, okay, okay. Yeah,
I'll end the meeting on my own. I'll end the meeting on my
No,
own.
I end the meeting. Okay, no problem, sir. Okay.
Okay, sure.
Thank you for all students.
Huh.
Thank you, sir.